last session of the last day in the furthest room in the whole convention center. I took the corner and I thought, I gotta be close to the end. I took the corner and I said, oh, there's more of it. Anyway, thank you for coming to today's session. We've got two great presenters on delivering facility management through digital twins, with digital twins through ArcGIS Indoors. Indoors is a very exciting product, lots of activity. I was saying that I've probably had more discussions about Indoors the last 3 days than probably anything else. It's very exciting that we've got two great presenters coming in. They're going to show, well, really two groups, excuse me, Mike, there are three of them, to talk about what they've been doing. First off, my name is Clay Starr. I am on the AEC team within Esri, focusing on growing our AEC community. Myself, I'm from the AEC community. I'm an architect, so that's kind of weird for an architect to work for a GIS company. I'll take your apologies after the session. It makes sense in my brain, however. So, without further ado, you didn't come here to hear me speak. I want to hand it over immediately to my new friend and colleague, Yavuz Eren. He's going to talk about how he has used Indoors and mapping with regard to how they're going to manage their facilities. I've learned that you're in the MipMap is a family business, so dad and brother in the audience, I think they're going to help participate in the session. So with that, Yavuz, take it away.
Thank you. Hi, I'm Yavuz Eren from MipMap Technologies, and I would also like to thank you again the last session, and everybody must be kind of tired. What I'm going to talk about today is primarily about digital twins, but how it relates to facilities. And I think this topic requires a lot of discussion over the next few years. So I consider that it's just at the beginning stages. So I would have loved to say, if it was the first day, please come by our booth and let's have long discussions. Unfortunately, that's going to be probably the next event. By that time, hopefully we'll have some more content as well. So I will quickly go through three examples. One of them is a university campus, another one is an office environment, and finally a manufacturing plant. So this is going to be primarily a live demo. I will not use slides, and if anyone thinks this is a bad idea, I agree, because 1 hour ago, our network the server started acting funny. Thankfully, Kamil was here, but if anything goes wrong, I'll switch to video and stills. So, my impression of digital twins as it relates to facilities is that if you've seen the movie Field of Dreams, if you build it, they will come. I don't think it lies, because we've had experiences where a comprehensive vision of a digital twin does not automatically incite participation and activity. This was our impression. So what we're seeking now is leverage points within the twin. Like, of course, you have to have something there. Like, you can't go with just concepts. But a basic twin with certain leverage points where the value becomes apparent to the end users. So extracting the leverage, of course, does require very close communication with the end user and a lot of iteration. So for those of you who are familiar with software development cycles, this usually is like a short, agile cycle where you talk to the customer all the time, you make some changes, you go back and forth. So how is this? This is risky normally, but what I'll try to demonstrate today is we have two foundations that make this possible. One is obviously the Esri ecosystem, which is like the bottom of the iceberg in terms of providing the depth of GIS data, not just GIS now, but also in the future when big data analysis comes into the picture. And the other pillar is our own proprietary technology, Evolved City. We've been developing that for about 5 years. Basically, our vision was to bring IoT workflows into a accessible framework. So I'll try to demonstrate some of those today. Let me start with the first demonstration. So this is not coming up. So I think I'll have to remove so PowerPoint was, okay, here we go. I will not use slides anyway, so closing that is not a problem. So this is our flagship, so to speak, when it comes to indoors applications. It is roughly, I think, 80,000 meters square, 3 buildings fused together to form a university campus. The architect, we met him. He was still suffering from it because that was a massive undertaking, and you can also see it in the way the building kind of comes together. But it's very complicated, obviously. It's one of those scenarios where indoor navigation really makes sense. Like, this is the lab area, and it's very easy to get lost in, and very hard to track assets and, manage the space. So we put this together, and all the bells and whistles, space management, and, we were talking about setting up kiosks and, for the students to find their way, all sorts of reservation ideas for the library and whatnot. And then it kind of stalled. I'm not sure why exactly. I think everyone was waiting for somebody to take charge. It's like, who's gonna set up the reservation for the library? I mean, is it the IT department? Is it the library management? I think one of the primary problems was, this is just my feeling, that there is a limited amount of geospatial maybe literacy, that people are not, although people are very familiar with space, I don't think they're very used to interacting directly with a digital system that just, is a twin of that space. So, of course, I don't want to drone on about hitting walls, because there is a nice end to this story. Not an end, but a nice, fresh beginning to this story. What happened was, some of the students in the computer science department, oh, by the way, the campus is primarily catering towards medical degrees. So there are a few engineering departments, and one of them is computer science. So they were studying Arduino-based electronics for one of their courses, and the students said, why don't we make room sensors, place them in the lab area, and then just publish them on the twin. So they started doing that, and we created dashboards to support them. So what is really fantastic about this, to me, is there's so much room to grow organically, because the next class to come in, they will put their own sensors and obviously hopefully put in other rooms, and then the campus is actually becoming smarter as the students keep working on the twin. And if there was no twin, it is quite possible that these sensors could just collect dust in a storage area, which I've seen in a lot of universities happen. And you would be surprised by, I don't know, in universities here, but you would be surprised by some top-level institutions where students do amazing work, geospatial work, like incredible designs each year, and then they just sit in a hard disk somewhere. Like, why don't you bring them together so we can play around with them in actual space? So we really enjoyed how this went, and we want to keep track of this. So maybe in a few years, when a department wants to study data, they might even reach a point where it's actually big data, so they can just run through this analysis and get a feel for what can be done with real-time geospatial data. Anyhow, so this is the first example that I wanted to share. So the second one is one of our new ventures. We wanted to use, I'm just going to run here and park this guy for just a second. I'll explain in a moment. Basically, gaming engines, gaming SDKs, we looked into, obviously, what is being done. Yeah, they all popped in. They all popped in. This is what we had trouble with. I'll explain what this means in just a moment. So, obviously, Esri is moving into the gaming engine technologies because of what they offer on the urban scale. And they're all quite fantastic. Real-time analyses, the weather, and everything, great. But our feeling was, indoors, what we do in the facilities, in our environments, the information is so rich that 3D makes, to me, more sense. Like, if you look at a floor plan and you try to put dots and icons and what we've done, and like thematic overlays, there's something that I think holds you back. 3D is so rich, and I'll kind of walk through the office, and I'll stare down every once in a while so I don't forget anything. So I'll just give you a tour of the office. Now, This is very similar to what it looks like. I'm not going to overlay it with some video, but this is very accurate. And the way we were representing it is with certain like landmark vehicles and some devices. So here we have people doing silly things. So here's the lesson. Don't mess with the guy who makes the twin. So these guys did. And this is what they are doing here in the twin. So additionally, now let me try to get back to the technical side. Real-time data. What those kids do with the room monitors is also something you can have here. So 1 hour ago, this was the temperature and the humidity and carbon dioxide levels in our office. Okay, that's step one. So what is this thing thinking around? The reason that I like 3D is the way that we pick up information in the peripheral. For example, libraries. If you go to the library to pick up a book, you're not like focusing in like a hawk. You start walking and you look around and you go, oh, there's so many kids. Oh, yeah, how has it begun? And you continue walking and you see like somebody signing a book and like, oh, wow, and then you go to your book. By the time you reach there, you're just accumulating so much relevant data, although you never planned for it. So this is our mindset here as well. As I'm walking through the office, I am going to see things that are actually relevant, even though I didn't aim for them. So this is one of them. There's a warning. Why? Because I didn't get data from here for 2 days. Why? Because I asked my sister to pull the plug. Sorry to put that on the demo, but you get the idea. Basically, you want to find out if there are problems. What else can you do? Now, one of the examples we love, and some of you might have seen this many times, so I'm sorry to those people, but one of the examples we love is our coffee machine. Historically, like computer science has that love affair with coffee and the webcam and everything. So we do as well. The coffee machine is not a special machine. It's not smart. It's not part of IoT. All it has is a load cell underneath it. So this purple thing here. What makes it? What gives it the semantics? Now this is where the power of our frameworks comes into the picture. The guy's kneeling here because I wanted to stay within the context. You can also browse, doesn't matter. But if you want to learn more, like at a glance I saw that there was coffee. At a glance I saw that it's been sitting there for 5 days. It's just water, by the way. There's a national holiday back home, so it's just water, not coffee. But I know when it was made. I know it's terrible at this point. But if I want to know more, I go in and I can look at the details, which is fine. But what is the magic sauce? It is our workflow blueprints. Basically, we have a system that allows us to add the meaning to what is in the field. This is both location, this is IoT real-time data, this is behavior of the people who are within that system. So for coffee, for example, the load cell, it just gives us weight. But we know that when you're making coffee, you put a certain amount of water at least, and coffee, and then it says, okay, 10 minutes later, fresh coffee. And I can say, wait, I want to warn people if it's stale. And by the way, I'm not kidding, I use this at the office. Like, I go there, run there, because I don't want to find out the coffee's stale by tasting it. So I go there and look. So, but for me, it might be 40 minutes. Some gourmet might say, no, after 20 minutes, you can't drink that coffee. So they can change the rules, doesn't matter. Calvin here said, well, I want to know when we're down to the last cup. So I'm just going to run and grab it. So he put another notification there. And so you just wire these together, and I can also open this up right here, so you have a better sense. So you wire all this together, and you set your own rules. Why is this important? Because as software developers, we know that the requirement analysis and the feedback to the customer, if it takes several months, and if you're off, and you're always off, you always have to revise something, that is such a wasteful cycle for everyone. You're making money, but beside that point, you don't want that. It's terrible. So here, we're letting the people define the semantics. So here, in terms of ArcGIS Indoors, what may make us a little bit unique is that the common operating picture for us does not have to be indoors. It could. Now, I'm just going to run out of the office and just step here. Got it. So here, I'm just gonna open up Indoors. Now, the same IoT data that's been streamed from the 3D twin, so to speak, is also published to ArcGIS Indoors. Why not? I mean, we need a common, what was the term? Common authoritative truth? I think I was like, I'm trying to quote Esri and I don't want to mess it up. So we want that. We obviously want that. We want the knowledge to be, stored in a common place. So this is the Indoors version. So again, we can look at sensors. We can put thematic information, which we don't want to do in 3D. Like, I'm not saying 3D does everything. Obviously, you want to switch back and forth. For example, you can look at lights, and you can superimpose that with, let's say, carbon dioxide levels and other things, and get a feel for your environment in 2D. That is fine. But what we do in our system is we put the geospatial element back into the workflow by, for example, asking who should make coffee. Now, within an organization, of course, coffee is just a simple example, but within organizations we have roles. So who with the right role is closest to this, target? So obviously with Indoors, it's not a matter of just a straight line. Whereas a person might be right behind the wall, they might have to walk around, there might be stairs or elevator. So you want to find the right person. So in that case, we query ArcGIS Indoors, get the result, assign the task, and we can also publish on the dashboard as well, however you want to access it. So in our case, it's a little bit different. It's that we consume Indoors as one of the services, but it can also be the primary operating picture. Okay, so I'm just gonna look down. Oh yeah, forgot about IPS. So IPS. Obviously, we've set up IPS. We, as a company, have the Indoor Specialty badge, for which we set up IPS, but we've also been playing around with IPS as well. The thing about IPS, if you're not familiar, is normally you set up beacons, and then you survey the Indoors area, and then from then on, your telephone is able to show you as a blue dot moving around in the space. Now this is fine, but this isn't always necessary. Depending on what problem you want to solve, this might be an overkill. For example, I'm just gonna kind of move in here. Can you see a little device, a beacon there? I forgot to put in the code for zooming in, but yeah. That's the contact I/O device. So we have one on that desk, and we have one on this bench, and we have one in one of the rooms here. I'm just gonna run over, there's one over here. So it took us maybe a day to set up the workflow to say, we can assign now a task to someone saying that take this asset from point A to point B. It's as simple as that. 3 beacons, and you just wire a few boxes together, and boom, you have an asset tracking solution with low fidelity. It might solve your problems, and I'll show you an example now as to why it solves problems. So here, looking at this information, this is our IoT toolbox, so to speak. There's like a solder and some electronic components, and it sits in 2 positions. It's either in the IoT room, or it's in beside this desk here. So it can be in 2 positions, and 7 days ago, someone put it here. So the twin, in that sense, not only gives you rich information, it also has the temporal element, because as you can predict, I can't walk in there and determine when it was put there. Now we're going to move into the final example and try to wrap it up. 5 minutes? Yeah, cool. So I will move into my final point. This is obviously a temporary UI. My graphic designer hates me for this. He's like, please let me fix it. Okay, so here we are. This is an actual factory floor of an electronics card manufacturing site in Turkey. They have like 3,000 workers and dozens of production pipelines. And these are quite intense. The production takes place 24 hours a day. Sometimes parts fly out like every 2 seconds or something. Now, when they came to us, but this is by the way simulated data. They definitely don't fail that much. But I can't show the actual data. So this is service-based data extraction from those pipelines, but I'm just simulating it for now. So what happens is, in real time, I can walk around, I can take a look, I can detect problems. And additionally, what happened here, the reason they got in touch with us and the reason we started working with them on the twin is the geospatial dark spots within the factory. Now, these production machines are relatively, I don't want to say smart, but they're connected. They send, all sorts of detailed information, exactly where the card is and whether there's failing or what company it's being produced for, everything's in there. But once it gets stacked here, and they call this the magazine, it fills it up. Once it gets stacked here, we have the problem of, geospatial awareness. They don't know what happens after that. You're supposed to go upstairs. I'm just gonna take myself upstairs. It's supposed to go, I can also, oops. Okay, I'm just gonna run. If you've seen Spaceballs, you get the reference, I guess. It wasn't intentional, by the way. I'm just gonna run. Okay, here I am. It's supposed to come here, these magazines. They don't know. Somebody might just leave them lying around. Somebody might take them 1 hour later. They don't know where they are. And here's a surprising news. In my experience, we went to dairy farms, airports, hospitals, various production sites. The geospatial awareness is incredibly lacking. And this is somewhat good news because there's a lot of business to be made, but at the same time, really surprising. Like, some incredible technology is being used, and they're just losing huge devices or huge assets. They just can't locate them. This blind spot is, to me, very, very surprising, but at the same time, it is such a perfect problem for the digital twin to solve. Because, as I showed you in the previous example, basically you can define a problem, add IoT, add your rules, and then your solution is right there. So in this case, we are working with them to access those magazines and to track them. But the thing about the twin is, in my opinion, one, yeah, you solve geospatial problems, perfect. Secondly, it gravitates multiple systems into common points. Now, this machine here, I showed several people within the organization, different stakeholders. First of all, I don't know if you, let's try to go back a little bit. Like when first Google Earth or like high resolution maps came out and you could zoom into your home and yeah, that's where I am. The same reaction with the twin. I live this all the time. Like, I show the twin to the stakeholders and like, oh yeah, that's our floor. And then they recognize it because of all the different landmarks. For example, my case slightly against 2D in this context is like, putting icons is not the same thing. This tells you what it is. So once they see it, they immediately start talking about the data and the production and whatnot. But the funny thing is they talk about different systems when talking about the same device. So one of the really great things about the digital twin is it forces these systems together. Because once you come into this environment, you kind of expect to be able to get all sorts of information about this device. So in this case, we are integrating different systems as well. So obviously, I'm not naive when it comes to 3D navigation, although I love gaming. I'm pretty sure not everyone will or should use a 3D twin. This should be the authoritative center, and then we should just consume it with 2D interfaces, web apps, mobile apps, or whatever. But it is my firm belief that multiple stakeholders within the environment should use this. And the reason is, not only does it sort of like a bit like a dichotomy in that it pulls systems together into common points, but it also kind of propels them forward. I'll just give one final example and, that shut off. Anyhow, okay, one final, perfect. 1 minute and then questions and answers. So one final example is when people were interacting with this twin, new ideas started popping up. And there, for example, here, there is a station where every morning, I'm I'm guessing roughly like 800 people have to go and test out their electrical insulation fans. I'm not sure if I get the term right. You have to go there, touch it on that device, wait for like half a minute, and then verify that they're not going to ruin the electronics production that day. But the thing is, there's among all this great technology, there's like a clipboard and they're signing it. So it looks silly, but from a software development perspective, it's not, because you don't want to spend 4 or 5 months building something just for that. But within the twin, that's maybe a week or 2, because you have the IPS, you have the rules. You can say, okay, setting up the rules every morning between 8 and 8:30, you have to be there. How do you know he's there? IPS. You have to wait 30 seconds, okay? And then the system might give a notification saying, if everything's okay, don't do anything. We'll just confirm it. If it's not okay, submit your problem. Easy peasy. If you have the twin and if you have the underlying technology. So suddenly things that are kind of annoying, but you don't want to fix it because they're expensive, become very, very feasible. And then the twin just gets even better. Another very brief example is, as we were running around, of course people recognize the space and they're like, oh wait, this area here, this is where we do production for Nokia. But Nokia production is a bit different. Now the environmental conditions are improved because they're very strict about it. So suddenly they're like, oh, you have the room sensors in your office, can we put one here, and can we set the rules, and on and on. So I really, really believe in the twin, and I think it has this incredible power, but again, just to come back to the initial point, I don't think you can just set up something very comprehensive and expect people to embrace it and just live in it. I think it has to solve several problems, critical problems, and then these have to compound until it really makes sense. That's my opinion, so we're pushing in that direction, and so the indoors industry is, I think it's just going to blow up. I agree with you, I think the excitement is real. But in my opinion, it's less of sharing a pie as opposed to trying to crack a huge cocoa, because it's a tough issue. But once we work, hopefully, together to share these use cases and successful implementations or different technologies, and once we crack it open, I think it's just gonna, the whole thing is just gonna flow over. So, thank you so much.
So yeah, we have about 5 minutes before our next presentation. I don't know what's meaner, is to not allow any questions or only give you 5 minutes. But let's take just a couple. Obviously, this is the last session of the day, so we'll hang out up here after it's all said and done. But any questions for Yavuz in the back?
Yeah, are you able to put things in there and see how they interact? You said that it's kind of a dumb question. So say you wanted to move or add a printer or something like that over on the left side. How hard is it to do that? And then does that from inside this interface?
Yeah. No, that's a great question. In this case, there is you can put anything you like. That's the power of the game engine, because each component you can break down into different levels of complexity. For example, the coffee machine is actually a composite object. Some parts of the coffee machine, when it, for example, the IoT data access element is a shared component because it has a certain bootstrapping phase where it gets in touch. It has, a data processing element inside it, which it shares with the room sensors and with the location-based asset tracking. So it shares it. So that's one part of the component. But the coffee itself was a unique implementation. So in this case, it can be custom. But over time, as these overlap, I could categorize, in software terms, we could generalize them and then have them as classes of similar objects. For example, from this example, the coffee machine would actually be visualizing an input to show fluctuations in real time. I could generalize this. Geometry is not important. I could just put in whatever mesh I like. But that behavior right now is custom. But the IoT behavior is not custom. That is a drag and drop component right now. So again, it depends on case, but there is a lot of room for creating reusable components, and that is exactly, I think, the way it should go. For now, it's a mixture of both.
Right, so like you could take that coffee machine and put another one in another room.
Oh,
and say, this is
yeah,
what it
yeah.
would look like
Yeah.
if we had a second coffee machine or just moved it.
Exactly. The duplication is the best part, obviously, because like those lines, they took a while to program, but then after that, it's just pop them all over the place. The limit obviously would be performance for the visuals or the computation. Sometimes it can stall if you're really pushing it. One thing you can do there is to use the geospatial context to pull the information. For example, you don't have to pull that IoT data until it's visible or until you're close to the machine. In that case, you could just bootstrap afterwards, just react to your location. So all of these things are so natural in gaming that to exploit them here is a great advantage. I mean, that's what we really enjoyed. One of the things we really enjoyed in the process.
So, Yavuz, you'll hang out here
Oh, yeah.
maybe after,
Yep,
talk
yep.
about, there's lots of cool questions. I want to get us moving. We made a quick shift on the
Okay.
hardware.
So just, is it okay if we bring it over there? Because questions might be relevant.
Hopefully we're good on batteries. Okay.